Hello friends, welcome to my YouTube channel Learning Videos. In this video we are going to find the Jacobian of the function, that is u comma v, which is given over here, that is 2x minus 3y, v is equals to 5x plus 4y. So we need to find the Jacobian of this function. So before proceeding to the video, if you like my content, please do hit the like button and please do subscribe to my YouTube channel. If you are getting any issues in running this program, please comment in the comment section. I'll try to solve the issue. So now we need to find the Jacobian of this function. U is equals to 2x minus 3y and v is equals to 5x plus 4y. So at the first, what we're trying to do is we are going to import SymPy. So what is SymPy? SymPy is the module that we are using in this program. So from SymPy, I am importing star. All the methods that are present in SymPy will be imported in our program. So next, I am declaring x and y as variables. So these will be considered as symbols in our program. That is, x and y will be treated as symbols. So now I am defining the function u. What is u? U is equals to 2 into x minus 3 into y. Next, I am declaring v variable, that is 5x plus 4y. So u contains 2x minus 3y and v contains 5x plus 4y. Next, I am storing that in the matrix form and in the variable a. So how to do that? We are using this method called as matrix, where m is capital, matrix, and I am passing my variable u and y. So this will be stored, u and y will be stored in the matrix form in the variable a. If you want, you can print this. So I'll print this, print a. I'll do this print a. I'll run this. So now you can see over here, what does our a contains? So this is our a. You can see my mouse hovering. So this is my a. What is it? It's 2x minus 3y and 5x plus 4y. It is in the matrix form. Okay, I'll comment this out. So since we have understood this, I'll comment this out. Next, I'm creating one more variable called as J matrix. So now in this, what is A? A is my matrix. So I'm calling a function called as Jacobian. And I'm passing x and y. So what does this Jacobian means? Jacobian means I'm differentiating u with respect to x. Next, I'm differentiating u and next I'm differentiating u with respect to y. So that will be our row 1. So next, I'm differentiating v with respect to x, and again I'll differentiate v with respect to y. So that will be our row 2. So a dot Jacobian will differentiate all these things with respect to x and with respect to y, and it will be stored in J matrix. Lastly, I'm printing my J matrix. You can see over p print J matrix. And afterwards, printing the J matrix, I'm taking the determinant out of the J matrix. I'm taking the determinant. So how to take determinant? So DET is a method. So call this method DET and pass your matrix, that is J matrix. So what does this J matrix contains? It contains Jacobian values. So at the last, I'm printing Jacobian J. So let us run this. So now you can see over here. So this is my matrix that I have got after A dot Jacobian. Okay, after line number 13. So this is the matrix that I have got, that is J matrix. So what does it have? It has 2, minus 3, 5 and 4. So we need to take determinant out of it. So how do we take determinant? Determinant is taken by 2 into 4 minus of 5 into minus 3. So 2 into 4 is 8. Minus of 5 into minus is 15. Minus of minus is plus. So that turns out to be, if we add 8 plus 15, it is 23. So that is our Jacobian value. So that's it, guys. Hope you have liked this video. And if you have understood something, please do hit the subscribe button. Till then, bye guys. Have a good day.